Chassis is the load-bearing framework of an artificial object which structurally support the object in its construction and function. An example of a chassis is a wheel frame, an underpart of the motor vehicle, on which the body is mounted. If the running gear such as wheel and transmission and sometimes even the driver seat are included, then the assembly is described as a rolling chassis. Hundreds of individual parts make up the essential component of the modern automobile. Much like the human body, these parts are arranged in several systems, each with a different function. Each system is necessary for making the automobile run, keeping it safe and reducing noise and pollution. Engine. The major systems of an automobile are the engine, fuel system, exhaust system, cooling system, lubricant system, electrical system, transmission, and the chassis. The chassis included the wheels and tires, the brakes, the suspension system, and the body. This system will be found in every form of motor vehicle and are designed to interact with and support each other. Fuel system. Gasoline must be properly mixed with air before it can be introduced into the cylinder. The combination of gasoline and air creates a greater explosion. The fuel pump draws the gasoline from the gas tank mounted at the rear of the car. The gasoline is drawn into a carburetor on some cars, while it is fuel injected on others. Both devices mix the gasoline with air. Approximately 14 parts of air to be 1 part of gasoline, and spray this mixture as a thin mist into the cylinders. Exhaust system. After the fuel is burned in the piston, the gases and heat created must be released from the cylinder to make room for the next intake of fuel. The exhaust system is also responsible for reducing the noise caused by the explosion for the fuel. Exhaust gases are released from the cylinder through an exhaust valve. The gas gather in exhaust manifold before eventually being channeled through the exhaust pipe and muffler, and finally out the tailpipe and away from the car. Okay, cooling system. Cooling system also maintain the engine at the temperature that will allow it to run most efficiently. The liquid cool system is most commonly used. The explosion of fuel in the cylinder can produce temperatures high as 4000 Fahrenheit. Liquid cooling system use water which is mixed with an antifreeze that lowers the freezing point and raises the boiling point of the water, guided through a series of the jacket attached around the engine. Okay, for the lubricant system, without proper lubrication, the heat and friction created by the rapid movement of the engine is parts will quickly cause it to fail. At the bottom of the engine is the crankcase, which holds a supply of oil. The pump powered by the engine carries oil from the crankcase and through a series of passages and hold to all the various parts of the engine. As the oil flows through the engine, it forms a thin layer between the moving parts so they do not actually touch. For electrical system, electrical is used for many parts of the car from the headlight to the radio, but it is chief function to provide the electrical spark needed to ignite the fuel in the cylinder. The electrical system is comprised of a battery, starter motor, alternator, distributor, ignition coil, and ignition switch. The starter motor is necessary for generating the power to carry the engine through its initial movement. Initial voltage is supplied by the battery, which is kept charged by the alternator. Transmission. Once the pistons are firing and the crankshaft is spinning, this energy must be converted or transmitted to drive the wheels. The crankshaft spins only within a limited range, usually between 1000 to 6000 revolutions per minute. Although the wheels spin at far lower RPMs, the range at which they spin is wider to accommodate the wide range of driving speed of an automobile. The next subtopic is mass, moment, and inertia. The moment of inertia, otherwise known as the angular mass or rotational inertia of a rigid body, is quantity that determines the torque needed for a desired angular acceleration about the rotational axis. Similar to how the mass determines the force needed for a desired acceleration, it depends on the body's mass distribution and their axis chosen. With larger moment required more torque to change the body rotation rate. It is an extensive additive property. For a point mass, the moment of inertia is just the mass times the square of the perpendicular distance to the rotation axis. Braking behavior. Most modern cars have brakes on all four wheels operated by a hydraulic system. The brake may be disc type or drum type. The front brake play a greater part in stopping the car than the rear one because braking throws the car weight forward on the front wheels. Many cars therefore have disc brakes which are generally more efficient at the front and drum brake at the rear. All these braking systems are used on some expensive or high performance car and all drum systems on some older or smaller cars. A direct acting servo is fitted between the brake pedal and the master cylinder. The pedal can work the master cylinder directly if the servo fails or if the engine is not running. A direct acting servo is fitted between the brake pedal and the master cylinder. The brake pedal pushes a rod that in turn pushes the master cylinder piston. If the vehicle fails because the engine stopped, for example, the brakes still work because there is normal mechanical link between the pedal and the master cylinder. But much more force must be exerted on the brake pedal to apply them. But the brake pedal also works on a set of air valves, and there is a larger rubber diaphragm connected to the master cylinder piston. Okay, next subtopic is a traction behavior. The first traction control system weren't completely made. Actually, they were probably boringly task-oriented and striving to meet performance goals in some lovely corporate building with vacation time and benefit, and nary a pair of black rubber gloves inside. That is fine. Engineers be that way. Reader will have to supply their own math tackling while reading how traction control works. So living in 21st century means that your car has a computer. It also means that your car probably uses a drive-by-wire system, which means there is no mechanical connection between the gas pedal and throttle mechanism. Pressing the accelerator pedal sends an electronic signal to the throttle and it is speed up your car. Okay, when the road is slippery for whatever reason, that light is likely to come on. Rain slick roads, itchy patches, and even wet leaves and can come between the grippy rubber of the tires and the nubbly surface of the road. When the tire catches an itchy part of the loses traction in deep puddle, the sensor node and the traction control system kick in. It also helps when you are accelerating from a stop. While your car is not moving very fast in those situations, having your wheels spin can still cause you to lose control. Best case scenario, you look like a fool on the local news with your tires spinning at the red light during your city's annual snow focal phase. Worst case scenario, you spin off the road and into a ditch. When you have got traction in four tires and they are spinning at the same rate, your car is far more stable, and that's why insurance company offer given discount for the car with ABS traction control. Insecure love stability. Okay, for the next subtopic is vehicle and body center of gravity. Center of gravity, also known as center of mass, is that point at which a system or body behaves as if all its mass were centered at that point, where the weight and also all accelerative force of acceleration, braking, and cornering act through it. Center of gravity location can be defined as the balance point of an object, the point through which a force will cause pure translation, the point about which gravity movement are balanced, the point which the body is hanged from it will stay balanced. Level as it is on the ground. What is the importance of CG? When making an analysis of the force applied on the car, the CG is the point to place the car weight and the centrifugal force when the car is turning or when accelerating or decelerating. Any force that acts through the GC has no tendency to make the car rotate. The center of mass height relative to the truck determines the load transfer related to, but not exactly weight transfer from side to side because body is already. Okay, next is the video. Okay, hope you enjoy the video. Thank you.